Hey everyone, in this video we're gonna go over candy party. Sorry, I was gonna do the easy version. But yeah, for this question, so let me go through a couple of examples so you can kind of see the patterns and everything. So this one is yes, this one is no, the solution. So let's do the yes one first. So basically the key idea is, well, let's talk about what the question is asking for first, okay? So basically, there's two constraints. One is we're given this array of elements. Our goal is to make them all equal, and the only operation we can perform on them is we add a power of to it, add a power of 2. We like transfer from one number to another. We can transfer any amount. I mean, as long as it's not more than the thing itself. So like you can do 3 for 2. You can't like give 3 if you are 2, but you can only give 2. But basically that, and we can transfer powers of 2 between them, and each number has to do at least one, or actually exactly one giving operation and one taking operation, right? So on receiving end and giving end, and our goal is to see if given array could be, using those operations, it could be made equal. So first, a simple check is we need to check the average. If the total sum of the array mod n is not equals 0, that means we have like a decimal, and we can't like use powers of 2 to get a decimal, at least not integer powers of 2. So we immediately say no. That's a simple case. But let's for these two, actually, the examples I picked from the test sample case, these two actually do add up to a integer. So let's look at an example. So we took the average of these guys, right? And then we calculate the difference from each element to the average. So 2, 1, 0, negative 1, negative 2. So the key observation is after all operations are done, each element could be expressed by this form. What is this form? The original element plus some power of 2 minus some other power of 2, right? That's exactly what the operation is describing. So if we have the differences here already beforehand. So what we need to do is we pre-compute the powers of 2, okay? Let me rephrase that again. So we pre-compute all the differences of powers of 2. Since it's only 10 to the 9, that's actually just 2 to the 30. So you can literally do n square algorithm. It will only take 900-ish, right? Because 30 times 30. So that's way under the time limit, so you don't have to worry about it. So you can literally compute all possible powers from 0 to 30 of 2 and like do all subtractions. Like in the code, this is what I do, like pre-processing. You see this? So, and I store them in a way so that I can refer to the 2x, and I can refer to the x and y, so the powers of 2 that I used. You can actually do the numbers themselves, like 2 to the x, 2 to the y, but I just ended up using the actual x and y, the exponents. It doesn't matter because both are unique to a given power of 2. But so it gives us like what x and what y we used to get this difference, right? So for example, to get a difference of 2, we need to do 2 square minus 2 to the 1. That's the only unique way to get 2 as a difference. You can try it, okay? So immediately, if any of the differences, for example, phi, you can't express it as this form, okay? So if any of the differences is a phi, you can immediately say no, like to the answer. But yeah, so basically you keep track of all this, and you can think of this, imagine there's like a big pool of think of it's like a pool of candies, right? Like everyone puts some candies into the pool, takes some candies, instead of one person giving to another person, because, well, actually the analogy doesn't quite work, but think of it that way, okay? But just you'll understand in a second why. So we can have like a map or hash map, which basically what it keeps track of is, so whenever we add a power of 2, it's like we're borrowing that power of 2 from the pool. And then whenever we give away a power of y, it's like we're adding to the pool, okay? So essentially you can just do this operation, and at the end you just need to check if all elements in map are equal to 0. If not, that doesn't work. Because what does that mean? That means one of the elements either needs something or it has to give away something to actually satisfy equaling this average number. But if it can't do that, that means the array is wrong. So let's look at this example. Go back to this example. So for this, I'm gonna just express all powers of 2. So for this, plus 4, to get 2, you get plus 4 minus 2, plus 2 minus 1. For 0, the 0 is a case you can skip all zeros, because if you think about it, 0 is you're adding the same number and you're subtracting the same number. So you're not doing any modifications to the pool of numbers. So for 1, it's plus 1 minus 2, plus 2 minus 4. And now they nicely cancel out. This plus 1 cancels out with this, right? And then this minus 2 cancels out this. This plus 2 cancels out here. Plus 4 cancels out minus 4. So at the end, all the elements in map will have 0 as the value. So then you can return S. Let's do this guy. So I already did some work here. So average is 10. So we calculate the differences. So we get plus 16. So as you can already see, there's no minus 16. So we can clearly say, like from this, that this example has answer no, because in our map it will look like m of 16 equals -1. So we return, if it's anything other than 0, we just return no. Okay, so where this gets tricky is actually like the other version of the problem. I didn't solve it, but like here they say you can do at most 1, so you can do 0 or 1. And this is tricky because now it's only not differences of powers, it could be just the powers themselves. So you can just give away like 32 and then not take anything, or you can just give it, or sorry, you can take 32 and not give away anything, or you can give away 16 and not take it. So like it's way more complicated, I would say. So yeah, that makes it tricky, but for this question, this approach definitely works. So let me go back to my code so we can look through all the steps I just talked about. So this is the step where we're computing all differences of powers of 2 and storing it so that we can get which powers they are. And so first we get the average, and then we loop through this. If it's 0, just like we don't care. Otherwise, if the diff powers doesn't contain it, remember I said 5 for 5 you don't have any answer. Like there's a lot of numbers you don't have any answer for, so you can just say break false. But otherwise, we increase the maps. The first number is what we are taking from the pool, so minus minus, and then we're giving away this much, so plus plus. And then we iterate over the map, and at the end we just check if any of them is not equal to 0, it's just false. And that's it. So yeah, thank you for watching, and please subscribe. Have a good one.